Hello, my name is Travis Dow, and this is our video demo for the midterm project. This is my group right here. So initially at the start of our main function, we're going to set this global variable selection to 0, and that's going to be used to track our user input. Then we're going to set this clock frequency, which we're using to calculate the frequency of the pulse generators. Then we call our initialization functions, the UART initialization function to initialize the provided UART module code, and then our IO initialization function, which we are going to use to initialize all the digital input pins we'll be using for the push buttons and for receiving the pulse wave. And then the change of notification that we'll be using for all our change of notification interrupts. We're also going to enable CNs for the 3 push buttons and initially disable it for the pulse gen pin because we want to only allow that to happen when we are in the pulse wave mode. Then we're going to set up our CN interrupts and initialize the timer that we'll be using for calculating the frequency of our pulse waves as well. Then we set the clock frequency. For the beginning here, we'll be using a clock frequency of 8 megahertz, and then we use the provided code to initialize the pulse generations. Then we just clear to the display to make sure that there's nothing currently showing, and then we just enter into our continuous while loop, which is calling this read multimeter function. And the read multimeter function is responsible for determining what mode our multimeter is currently in. So initially we just set it into selection equals 0, which puts it into idle until a push button is interacted with. If push button 1 is pressed, then selection 1 is triggered, and this all happens in the CN interrupt. So we can see when a CN interrupt is flagged, if PB1 was last pressed, we go selection equals 1. If PB2 was last pressed, then selection equals 2. If PB3 was last pressed, and the selection is currently not 3, we enter into selection mode 3. And then going back to the multimeter, so if push button 1 was pressed, we're just going to call the display voltage function, which calls this read voltage function, which is just calling our ADC module to determine what the voltage to the pin is. For pin 8 to calculate our voltage input for the voltmeter. Similarly for selection equals 2, which means if push button 2 is pressed or push button attached to RE4, we're going to go into ohm meter mode, and that's just going to call this ADC module for pin 16 to determine what the voltage there is so we can calculate the resistance. And then lastly, if selection is 3, what's going to happen is the next time that there's a change of notification interrupt, because the digital input to the pin RB12 is high, we're going to start a timer. If it's the first time, we're going to start a timer. And then the next time we get a change of notification interrupt where we go from low to high, i.e. the next time the square wave goes to a max amplitude, that'll be 1 period of our wave. So we're going to stop the timer at that point and then call this display pulse function so that we can display the frequency, and we're going to reset the timer. So this display pulse function is responsible for calculating the frequency that we'll be using, and that gets displayed to the terminal. And the way that's being calculated is we're just taking the total time, which is the elapsed time for the timer, multiply that by 2, divided by the clock frequency that's currently set, and then calculate the frequency using that by dividing 1 over that value divided by 1,000, so it's in kilohertz. And then we display that frequency value to the terminal by converting it to a string from a floating value. And then we do the rest of the formatting and write the amplitude, which is going to be around 3.25 volts because our MCU is set to a power supply of 3.25 volts. And it's a digital high value. And then likewise for the voltmeter and ohm meter, it's the same way we did it in the previous project. We just calculate the voltage based on the ADC value times the maximum voltage from the MCU, 3.25, divide that by 1024, that's our voltage. And for resistance, same thing, we calculate the voltage with that return value from the ADC. And then just convert that into a resistance using a voltage divider calculation. So to illustrate all the states here, I'm just going to run this. So initially we're going to do, according to the assignment, we're going to do the first test setting, which is 8 megahertz, and the row div is 9. And so just to establish, I can show you over here is our hardware. So if I show you just first, if I push button 1, we're going to go into voltmeter mode. And if I push button 2, we're going to go into ohm meter mode. The potentiometer is currently hooked up to the voltmeter, so I'll just go back into the voltmeter mode here, and we can see that as I twist the potentiometer, we're going to get a change in the voltage displayed to the terminal. There we go. And then for the ohm meter, I have to remove the potentiometer. Sorry. Put it in the right place here. There we go. Okay, and then so if we can see we just have some noise in the voltage signal now. So if I switch back to the ohm meter mode, now we're back in ohm meter, we can see that the resistance has changed, and similarly if I turn the potentiometer here, we can see the resistance changing for the ohm meter. All right, and then I'll put it into pulse meter mode. And so that's going to display, so right now for test settings 1, we're getting 15.68 kilohertz with an amplitude of 3.25 volts approximately. And then I'm going to have to change this. So for test setting 2, we're going to set it to 15 here. There we go. Save that, run it again. Clear the screen. Wait for it to build. Okay, and then I'll put it back into pulse meter mode here. There we go. So we can see we're getting 0.244 kilohertz, and again, our digital high amplitude, 3.25 volts. All right, and then for the next one, 500, and we're gonna make it 9. And I'll have to change this to 500,000. There we go. Build that. Sure it goes through. Okay. Oh, we got a little bit of leftover stuff there. I'll clear. All right, so I'll put it into voltmeter mode. Oh, sorry, I gotta change the baud setting here. There we go, clear screen. Okay, so we can see we're in voltmeter mode again. And then I'll put it back into pulse meter mode there. And we can see that we're getting 0.98 kilohertz and a digital high amplitude of 3.25. And then for the last setting, sorry, it's 0111. There we go, run that. Clear the screen, all right. And then I'll put it back into voltmeter mode, okay, and then switch it over to pulse meter mode. We can see we're getting 3.968 kilohertz and our digital high voltage of 3.25. And there I can switch it between modes if we want. And just the potentiometer is still hooked up to the resistance, so or ohm meter I should say, so I'll just show you that that's still working for the different clock frequency as well. And if I remove the potentiometer here, sorry, and stick it in there. Oh, sorry. And then we can see our resistance has gone up. And if I put it back into voltmeter mode, we've got our potentiometer attached to the voltmeters now. And if I move this, it still changes. So it's working with a different clock frequency as well. All right, thank you very much.